Today we're going to be solving right triangles, and hopefully you've got your notes at the bottom of page 1. These are the chapter 9 notes, bottom of page 1. Excuse me. So for each one of these 3 examples that they give us, we are asked to solve the triangle using the diagram and the given measurements. So what I've done is I've given you 2 parts to the triangle. Remember, there are 6 parts to a triangle. There are 3 angles and 3 sides. Now, one thing that you should always note is that uppercase letters are used for the angles. You can see the capital A, capital B, and capital C. They're representing the angles of this triangle, and the lowercase letters, lowercase a, b, and c, represent the 3 sides. Also, by convention, when you have an uppercase letter like A down in this corner, you go directly across from the uppercase A letter and you get the lowercase a. Here you have an uppercase B up in this angle, and across from the uppercase letter is a lowercase b. And here we have angle C as our right angle in the triangle. This is an uppercase C, and then the lowercase c is directly across from the right angle. So that's something that you should note, is the uppercase, let's see if you can read this, the uppercase letters are angles, and the lowercase letters are sides. And across from the uppercase are the corresponding lowercase. Let's see if I can try to focus this a little bit better. There we go. All right. So what we're given in question number 15, this diagram refers to question number 15. Whenever you're solving triangles, you should always draw the triangle that they're asking about. In this case, they're asking about triangle ABC. So I just drew an ABC down here for you so you wouldn't have to do it yourself. And what they're giving us is that angle A is 14 degrees. So down here in angle A, put 14 degrees. You know angle C is 90 degrees because they've indicated that as the right angle. And they're giving us that the side A, little a, is equal to 6. So mark that with a 6. And if we're asked to solve the triangle, then we have to give what all 3 angles are and all 3 sides are. And we're going to use trigonometry to do this. First of all, we know that the 3 angles in a triangle add up to 180. We already have angle C as the 90-degree angle, so angle A plus angle B add up to 90 degrees because those are the other 2 angles in our right triangle. Gosh, that still looks blurry. So since angle A is already 14 degrees, we can say 14 degrees plus angle B is equal to 90, and 90 minus 14 means angle B is equal to 76 degrees, 90 minus 14. Excuse me. And angle C is 90 degrees. So we have the 3 angles, A, B, and C. To solve triangle ABC, we also need the 3 sides. So we're already given angle, or side A, which is 6. Now what we can use is trigonometry, right triangle trigonometry, to find side B. So let's use this angle A is 14 degrees. We'll just mark it with our little arc. And what we have is something very blurry still. Gosh. There we go. We have the side opposite angle A, so I'll just put OPP for opposite side. Side B is the adjacent side, so I'll mark that with an ADJ. And side C is the hypotenuse, so I'll mark that with the HYP. So we know opposite, adjacent, and hypotenuse. That's from angle A that was given to us. If we want to know the adjacent side, and we already know the opposite side, then we're going to use SOHCAHTOA. We can write SOHCAHTOA off to the side, SOHCAHTOA, to help us remember which one to use. Since we know the opposite side and we're trying to find the adjacent side, we can use the tangent function because that refers to the opposite and the adjacent side. So what we can write is, I guess I'll write it down here, we can write that the tangent of angle A, which is 14 degrees, is equal to the opposite side divided by the adjacent side. We don't know what that is, but it's little b. You can put a 1 underneath the tangent, and now we have two fractions equal to each other, so we can cross multiply. Tangent of 14 times b, which is b tangent 14, is equal to 6 times 1, which is 6. So this is just a cross multiplication from this step to this step. The last thing we can do to solve for b is we can divide both sides by the tangent of 14 degrees. So 6 divided by the tangent of 14 degrees will give us what little b is. So now I'm going to pull out my calculator, and make sure every time you use a calculator you press the mode button, and make sure the mode is degrees, or else you're going to get the wrong answer. So what we're going to put in our calculator is 6 divided by the tangent of 14. So 6, press the divided by button, and then the tangent button of 14 degrees. You don't have to close up the parentheses if you don't want to. And they want us to round these. It doesn't say how they want us to round these, so I guess we'll round them to the nearest tenth. So side B is 24 the 6 rounds the 0 up to a 1, so 24.1 would be how long side B is. 24.1. The next thing we're going to find is side C. In side C you can find a couple different ways. There's actually about 4 different ways you can find how long side C is. You can use a squared plus b squared equals c squared if you want to, because now we know both the opposite and adjacent sides, and now we could use the Pythagorean theorem. That would be fine. Just show your work however you're going to use it. Or we could use trigonometry. We know the opposite side is 6. We're trying to find the hypotenuse, and I'm looking over here, and opposite divided by hypotenuse, we will be using the sine function, and it's the sine of angle A. So here we can say the sine of angle A, which is 14 degrees, is equal to the opposite side, which is 6, divided by the hypotenuse, which is c, which we don't know. And then just like before, we can put a 1 underneath the sine of 14, cross multiply c times the sine of 14 degrees is equal to 6 times 1, which is 6. And then if you divide both sides by the sine of 14 degrees, you're going to solve for c. So in our calculator, 6 divided by the sine of 14 degrees is equal to 24.8, which makes sense because your hypotenuse should be your longest side whenever you have a right triangle. So C will be 24.8. And they haven't given us units, whether it's centimeters or millimeters or whatever, so we'll just put C as 24.8. Box that in. That's little c. Little b is 24.1. We found that up there. A was given to us, So we have A, B, and C, and we have angle B, we have angle C, and we were given angle A. So now we have all 6 parts of the triangle, the 3 angles with capital letters, and the 3 sides with the lowercase letters. So there's your first one. Question number 16, I've redrawn another triangle for you, and I've given you that angle A is 57 degrees, so we're going to mark that with a 57. Angle C is 90 degrees, and they're telling us that side B is 12. So again, we're going to mark side A as the opposite side because we're given angle A. Side B is the adjacent side, and side C is the hypotenuse. So since we know angle A is 57, angle B is equal to 90 minus 57, because they add up to 90, all 3 of them add up to 180 in the triangle. So, excuse me, angle B, 90 minus 57 is equal to 33 degrees. And angle C, because it's a right triangle, is 90 degrees. So now we know all 3 angles. Angle A we were given, angle B we calculated, and angle C is our right angle. So there wasn't much calculation for that one. Now what we have is the adjacent side. And if we wanted to find the opposite side, we look over here, and the tangent function refers to opposite and adjacent. So we're going to use tangent since we know the adjacent is 12. So we'll say the tangent of angle A, which is 57 degrees, is equal to the opposite side, A, over the adjacent side, which is 12. Put a 1 underneath the tangent and cross multiply. A times 1 is A. 12 times the sine of 57, or tan of 57 is 12 tan of 57. So in this case we're going to be multiplying instead of dividing. So we pull out our calculator and do 12 times the tan of 57 degrees. And it looks like it's 18.47, which rounds up to 18.5, which is B, or A, equals 18.5. And then the last thing to find is side C. And again, if you wanted to use the Pythagorean theorem, a squared plus b squared equals c squared, that would be fine. I'm going to use trigonometry now. We know the adjacent side, and we want the hypotenuse. So the cosine function refers to the adjacent divided by the hypotenuse. So we can say that the cosine of angle A, 57 degrees, is equal to the adjacent, 12, divided by the hypotenuse, C. Put a 1 underneath the cosine of 57 and cross multiply. So this says C times the cosine of 57 is equal to 12 times 1, which is 12. And if you divide both sides by the cosine of 57, you're going to get side C. So 12 divided by the cosine of 57 is 22.03, which just stays at 22.0. Oops, C is equal to 22.0, which makes sense. It's the longest side. B is 12, A is 18.5, and C is 22. They're all around the same length. I mean, none is really, really huge compared to the other, but side C is the longest one because the hypotenuse is always the longest. The last example here for the day will be example 17. So we're given angle B up here in the corner, which is 32 degrees. Angle C is 90 degrees. And we're given that side C, we're given the hypotenuse this time. C is 20.4. hypotenuse. Now we're talking about angle B up here, and across from angle B is lowercase b, which now is the opposite side down here at the bottom. C is still our hypotenuse, and right next to angle B, angle A is the adjacent side. So they're telling us the hypotenuse and angle B. Now we can figure out what angle A is, because A plus B add up to 90, since C is already 90. So 90 degrees minus 32 degrees is angle A. So that looks like it is 58 degrees. I wish it was 58 degrees today. Melt some of the snow. So angle A is 58, and we already know angle C is 90 degrees. So we know all three angles. We know one side. Let's get the other two using trig. So angle A is the adjacent. We want the adjacent. We know the hypotenuse. So we're working with adjacent and hypotenuse, which is the cosine function. So we can say the cosine of, now we're working with angle B up here because we're given angle B. The cosine of B, which is 32 degrees, is equal to the adjacent divided by the hypotenuse. And now we can solve for the adjacent side by putting a 1 underneath. Cross multiplying. A times 1 is A. 20.4 times the cosine of 32 degrees will go in our calculator. That's right. Yeah. So it looks like, excuse me. It looks like 17.3 will be our side A. And now the only thing left to find is side B. Side B is the opposite side, and since we know the hypotenuse, opposite over hypotenuse is the sine. So the sine of angle B is opposite divided by hypotenuse. So we have sine of 32 degrees is equal to the opposite side, which is B, divided by the hypotenuse, which is 20.4. Put a 1 underneath. B times 1, which is B, is equal to 20.4 times the sine of 32 degrees. So we take out our calculator, 20.4 times the sine of 32 degrees. And it looks like it's 10.8 if you round it to the nearest tenth. So B equals 10.8. And making sure that everything makes sense, 20.4 is the longest side, 10.8 is the shortest side across from the smallest angle, and 17.3 is across from the 58 degree angle, which is the middle side. Remember, the longest side is across from the largest angle, and the smallest side is across from the smallest angle. So that's how you solve triangles. Solving triangles, remember, it means to find all three angles, A, B, and C, which in a right triangle, if you're given one of the other two angles besides the right angle, it's just a subtraction from 90. And then you can use right triangle trigonometry, sine, cosine, and tangent. You'll be given one of the two sides, and then you have to find the other side using your calculator. And that's it for today. We'll practice this tomorrow.